Hey guys, this is Mr. Lowry. This is an in-class assignment that we started on Monday, 11:30. If you're in cohort A. If you're in cohort B, this is from Tuesday, 12:1. We talked a little bit about how sequences are similar to functions, and we've been studying functions a lot lately and representing functions in different ways. This assignment here is to help us start thinking about patterns and sequences, because we're going to be talking a little bit about sequences as functions this next week, or in the next lesson. Okay, so this is an assignment that we did in groups. If you're at home, if you're working from home, then you'll want to download this and work on it on your own. We will be turning it in eventually, but we're going to work on it a little bit more later this week. So I'm going to help you get started on this, since you at home, you don't really have a group. You should be able to do a lot of this yourself. So what I would do here first is do as much as you can on each pattern. Now the first several questions are not too bad. Maybe questions 1 through 4 are pretty easy. Okay, 5 and 6 are a little bit harder, because you have to actually kind of explain in words and try to write an equation for what's happening here. So I'll get you started here, and I want you to try to do as much as you can, and then we'll come back and maybe talk about those other things. There's 4 patterns here. So here's pattern 2. We want to look for the pattern, figure out what's happening, and kind of describe it with words, with the table, things like that. And then here's pattern 3. Okay. Again, the first 4 or 5 questions are usually pretty easy. The hard part is where it gets towards the end, and you have to kind of do a little bit more thinking. Okay, let's get started. Okay, first off, we want to draw the next figure. So we have figure 1, figure 2, figure 3. The next figure will be called figure 4, and we want to see what that's going to look like. So we need to figure out the pattern. Well, we got a cross every single time, right? But it looks like the cross is getting longer and taller. So here we have this middle block. I'm going to mark this by shading it in. Okay, and this one has one block on each side of that middle block, and then we have 2 on each side of the middle block, and then we get 3 on each side of the middle block. So you could probably figure out what's going to happen here, right? We're going to have the middle block, and then figure 4 will have 4. Here's the blue one. We'll have 4 on each side. Okay, so I'll let you kind of fill in the rest of that. I think you could probably do that on your own. Okay, so next up, complete the table. Well, in figure 1, excuse me, we have 1, 2, 3, 4, 5. We have the middle guy, and then we have the 4 extra. Okay, in step 2, we have the middle guy, and then we have 2 on each side. So we got 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 there. On step 3, we have the middle guy, that 1 right there. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hang on a second. I think I counted these wrong. I forgot to count the middle one here. Sorry. You're probably like, wait, it's not 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 9 of them. There's 8 on the outside, but I forgot to count that middle guy. Okay, so same thing here. Now let's kind of be creative about this. Let's see if we can figure out an easier way to get here. Okay, so we have this 1, right, every single time. But then we have 1, 2, 3 times 4, because there's 4 sides. So basically what we have is 1 plus 3 times 4. That's going to be 13. Okay. This one right here is 1, that middle guy, plus 3 times, plus 2 times 4, excuse me. And then this guy is 1, that little middle guy, plus 1 times 4, right? So let's break this down a little bit. Where is the 1 coming from? Well, that's how many blocks are on each side of the center one, right? So where's the 4 coming from? Well, because there's 4 sides. So here's the middle guy, and then we got 1 on each of the 4 sides. So here's the center guy, plus 1 on each side times 4 sides. Okay, here's figure 2. The center guy, plus 2 on each side times 4 sides. Okay, here's the third one. Here's the center guy, 1, plus 3 on each side times 4 sides. All right, so there's a pattern here that you're going to start seeing. Okay, this will actually help you down below a little bit. And if you take a look, every time 5, 9, 13. Well, 5 to 9, that's like I'm like adding 4 right there. Right? And from 9 to 13, I'm also adding 4. I'm just adding a square on all 4 sides every time. Okay, so on the fourth one, instead of having 3 on each side, I'm going to have 4 on each side. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. All right, so again, I'm going to let you kind of go from there, fill in the rest of the table. You can already see the pattern, right? Kind of adding 4 every time, and you can also even represent it this way with the one middle block plus the number on each side times the number of sides. Okay, describe the pattern in words. Now, we kind of talked about this already, right? Every time you go up a figure number, then we're adding 4 more at the edges, right? You could also, you could use different words for that. You can say, well, there's always 1 in the middle, but then I do, a different number on each side times 4 or something like that. Okay, find the number of tiles for figure 10. Okay, we don't, there's a couple ways to get here. We can use the table. We can keep going with the pattern. So plus 4, plus 4, plus 4, plus 4, plus 4, plus 4, until we get to step 10. But we can also use this idea that we've gotten before. If you think about it, step 1, step 2, step 3. Right? Every time we have the figure number, which we also call the step number sometimes, because this is like step 1, step 2, step 3. The figure number matches the number of blocks on one side, right? 3 and 3, 2 and 2, 1 and 1, right? So if we were on step 10 would have 10 on a side, right? So we'd have 1 in the middle, that same little blue one that we've been talking about, okay? And to that, we would have to add 10 on each side of the blue, but there's 4 different sides, right? So 1 plus 10 times 4, that should be 41. Okay, now if we want to double check, we can keep adding, right? So plus 4, plus 4, plus 4, plus 4, and you can kind of like extend your table if you wanted to, or double check to make sure that if you keep adding 4 a bunch of times, that you are going to get to 41 on step 10 or on figure 10. So step and figure number are kind of used interchangeably. Oh, sorry, I put this in the pattern. This goes down here. My bad. You have some description written there for the pattern. That's your own words, but you can kind of see what's happening. We've talked about that. Okay, describe the relationship between the step number n and the number of tiles. Okay, this is, again, the language is a little bit hard. Step number is the same as figure number, okay? So if we say here n equals 1, n equals 2, n equals 3, what are we talking about? We're talking about what step we're on, right? Like what figure number? How does the figure number relate to the picture, right? That's what we're asking. Well, the figure number is the number of blocks on each side of the middle square. So that's one way to do it. You can kind of describe what's happening there with that relationship. You can say, okay, I got that middle block, right? Now I take the step number and I multiply it by 4, and I get the number of blocks outside, right? So step number 3, I take 3 and I multiply it by 4 to get all the blocks outside the middle guy, and then I add the middle guy. And that's how you get the number of tiles. Okay, so how does that help us solve an equation, okay? So let's say, number of tiles, I don't know, we can use T for that, the number of tiles equals. Well, how do we get it? I mean, up here what we did is we took the step number and we multiplied it by 4 and we added it to 1. So that should work for every step, right? the same thing's going on here. We took the step number, 1, 2, 3, whatever it was, and we multiplied it by 4, and then we added 1 again. So we want to basically kind of write an equation that says that the number of tiles is 1, that middle guy, the middle blue guy, plus the step number, which we're calling n, times 4. Okay? So 4 times the step number will give you the number of tiles on the outside, and then you add that to the middle square. That's one way to write it. It's not the only way to write it, because you could also write it like this. Okay? Notice that this looks very similar to slope-intercept form. Kind of looks like a 4x plus 1 almost, or a mx plus b, right? Slope-intercept form. So our constant rate of change, our slope, is 4. We're going up by 4 every step. Every time we change to a different figure, we add 4 more. And we start with 1. This is like our y-intercept. So slope, constant rate of change, is 4. Our y-intercept, our starting place, is 1. Okay? Kind of interesting. If you go back here for a sec, you can actually make a figure 0. What would it look like? Well, we would subtract those 4. So all we would have is the starting block. So we could add to our table figure 0. It doesn't really make sense to have a figure 0, but if we did, it would have 1 block to it. Okay? So when we look at this equation and we break it down, what it looks like is a y-intercept, a starting place, start with 1 middle tile, and then add 4 tiles for whatever step number you're on. That's essentially what's going on here. Right? Start with the middle guy and add 4 tiles for every step, whatever number you're on. So this is 3, so 4 times 3. Right? And that gives you 13. So that's not everything. You got to go in and write some more. We didn't write it all out, right? You got to use your own words on number 5 and number 3 and things like that. You need to fill in the table, finish the drawing, right? Things like that. But you kind of got the idea and you kind of got the pattern, okay? So this pattern is a linear pattern. It's got a constant rate of change. It increases by 4 every single time. Okay, now the next patterns aren't linear, okay? So don't expect them to be linear every single time because they're not going to be. We're going to compare different kinds of patterns because just like different kinds of functions, like we talked about linear, quadratic, cubic, absolute value, there's also different kinds of patterns and sequences. And this one happens to be linear. Okay, let's take a look at the next one. All right, so what's happening here? Well, we got 2, and then we got 4. It's getting taller, right? And then we flip that over, and we got 8, and we kind of flip it over this way. So it kind of looks like we're kind of copy this way, and then we take this guy, and we copy it this way. And then we take this guy, 3, and we copy it this way to get 4. So if we take this guy and copy it over here, we should get figure 5. So 5 is like this guy, number 4, but with another copy over here. Okay, so this is figure 5, fig 5. Do a copy of 4, and then make another copy of that over here. Okay, now let's look at the number of tiles. Okay, so figure number, that's n. Number of tiles, we'll call that t. Okay, so for figure 1, we got 2. For figure 2, we got 4. For figure 3, we're just counting about 1, 2, 3, 4, 5, 6, 7, 8. We got 8. For figure 4, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. All right, so what's the pattern here? 2, 4, 8, 16. Well, we're doubling, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 16 is... Sorry, 8 times 2 is 16. What's 16 times 2? That's going to go here. Whatever that is times 2 is going to go here. Okay, so we have this pattern of multiplying by 2. The last pattern was an add pattern. Add 4 every time. This is not an add pattern. This is a multiply pattern. So times 2, times 2, times 2. And that's going to keep continuing. Okay. So describe the pattern in words. Okay, well we're taking the figure, the number of tiles, and we're doubling it every time we increase to a different figure. Okay, find the number of tiles for figure 10. Well, we could keep doubling, right? So double to get 5, double to get 6, double again to get 7, double again to get 8, double again to get 9, double again to get 10. Keep doubling until you get to 10. See how many that's going to be. It's going to be kind of a big number. Okay. this is where it gets a little tricky. I'm going to have you guys, I think you guys can probably figure these out with what we've talked about. All right, these are the tricky ones though, okay? All right, let's take a look for a second. Now, in order to kind of help me with this, I'm going to add a step 0, kind of like we did before. So I'm going to go figure 0 or step 0. Well, if we're doubling this way, 2, 4, 8, 16, then we should be halving. So 16 divided by 2 is 8, 8 divided by 2 is 4, 4 divided by 2 is 2, but 2 divided by 2 is 1. That's what figure 0 looks like. So let's add a little entry here to our table. So for figure 0, which doesn't really make sense to have a figure 0, but if we did have a figure 0, it would have 1 tile in it. So this is kind of like our y-intercept here. This is like our starting place. Okay. The difference is this is not linear. It's a different pattern. Okay, so let's think about this for a minute. Let's start here at 0. I know it's kind of weird to start at 0, but it'll make sense in a second. And let's just count how many times we've multiplied by 2. Okay? All right. If I'm starting at step 0 and I want to get to figure 3, I have to multiply by 2. 1, 2, 3 times, right? So another way to write step 3 to get the number of tiles, it's the original 1 times 2 times 2 times 2, right? Let's add that up here. Times 2 times 2 times 2. So in order to get to figure 3, I had to multiply by 2 3 times. So this is like 1 times 2 times 2 times 2. Okay? Let's think about this one. For step 2, it was 1 square, double it, so times 2, double it again, times 2, and now we're at 4. So this is 1 times 2 times 2, right? Okay, for step 4, if I start at 1 square and I double it, times 2 times 2 times 2 times 2, I have to multiply by 2 4 times. 1 times 2 times 2 times 2 times 2. All right, so what's happening here? Let's fill in the rest of the pattern. This is 1 times 2. And this is 1 times 2 times 2 times 2 times 2 times 2. Okay, so we're doubling, right? Okay, we're timesing by 2. We get an extra 2 every single time. The trick here is to talk about exponents, okay? So what's another way to write 2 times 2 times 2? What's another way to write 2 times 2? What's another way to write 2 times 2 times 2 times 2 times 2, right? This 1 isn't really important because anything multiplied by 1 is just itself. Okay, so this is 2 to the 1 power. This is 2 to the 2 power. This is 2 to the 3 power, right? Exponents. Repeated multiplication we represent with an exponent. 2 times 2 times 2 times 2, that's 2 to the 4th power. And 2 times 2 times 2 times 2 times 2, that's 2 to the 5th power. Right? Kind of interesting. So that's the relationship. Notice, for figure 4, I have 2 to the 4th tiles. For figure 3, I have 2 to the 3rd tiles. Okay? So what about figure 10? Well, for figure 10, I should have 2 to the 10th tiles. I want to just show you something really quick. So I got up to get a calculator. You may not have a calculator like this exactly, but you can find a calculator online to use, like Desmos. We'll have a calculator. But in our class set here, or maybe one similar, there's a power key. So this squares everything. Like if I want to do 9 squared, that's how you do it. The little x to the square, right? Okay, 81. This one does a power of your choosing. Okay, so if you wanted to do like 2 to the 3rd, for example, that's 8, right? 2 to the 3rd is 8. Yeah, well, what's 2 to the 4th? 2 to the 4th power is 16. So 2 to the 5th is going to get you this guy. 2 to the 6th is going to get you this guy. Now, you don't have to do it that way because you can just double, right? So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is blank. You'll fill it in. Whatever that number is times 2 gives you this one. Okay, so there's a couple of different ways to do it. But the idea here is the relationship between the step number, or the figure number, I should have said figure number, but step number, same thing, and the number of tiles has to do with powers. Okay, it's 2 to the power of the step number. The step number gives you how many times you've doubled the amount of tiles when you jump up to the figures. So this power of 2 is whatever step you're on. It's how many times you've multiplied by 2, how many times you've doubled. So at figure 5, we've doubled the amount of tiles 5 times. Okay, so let's write an equation. Okay, kind of tricky, but the number of tiles, t, is equal to 2 to the figure number, right? Whatever the figure number is goes here. We do 2 to that power. There's a bunch of 2's. It's always going to be a bunch of 2's multiplying, right? So the base is always 2. 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. We just got to figure out what the figure number is, or the step number is, do 2 to that power, and we get the number of tiles. Okay, so fill the rest of that in. I know that some of this is tricky, especially this one, which is why I wanted to help you with it, and kind of walk you through that pattern here. Okay, all right, now you should try to do as much of this as you can. We've already walked through a couple examples. I didn't give you everything, but I gave you a lot of it. Okay, now this is a completely different pattern. It's not linear. It's not like the last one either. It's its own thing. So we want to start by seeing the pattern here, if possible. Once we see that pattern, we can start to kind of figure out what's happening. So a couple things I want to point out. Okay, first off, there's like a square in each one of these with extra 4. So one of the questions, number 5, asks you what's the same and what's different. These guys right here, this guy, this guy, this guy, this guy, they're always there. Those 4 corners pieces are always there. 1, 2, 3, 4, 1, 2, 3, 4. Those aren't really changing. What's changing is the inner shape, this guy. And notice that it's always a square. Okay? This square right here is a 2 by 2 square. This square right here is a 3 by 3 square. This square right here, it's just a 1, right? We'll call it 1 by 1 if we want. Okay, we can get the number of squares in here almost like an area. The area of a square is base times height, right? So 3 times 3 is 9. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 squares in there. Okay, 2 times 2 is 4. 1, 2, 3, 4. Right? 1, of course. Okay, so the next one, 4, step 4, or figure 4, should have a 4 by 4 square in it. Right? Okay, there's your 4 by 4 square. And onto that, we have the 4 on the outside. Okay. Question, how many squares are in here? How many little tiles? 4 times 4, right? 4 times 4 is 16. So there's 16 of those little guys, plus 1, 2, 3, 4 on the outside. So there's going to be 20 in that guy. Really important idea is this idea of squares, right? 3 squared is 9. 3 times 3, that's 3 squared, right? 2 squared is 4. 4 squared is 16. Okay, so think squares. Literally and like symbolically. Okay, this is literally a square, but 4 squared is equal to 16. That's where the word square comes from, actually. It comes from like literally a square, and you're doing area, 4 times 4. Okay, so you got the next one in the sequence, kind of know what's going on. Let's count them up. Okay, so we got 1 in the middle plus the 4 on the outside. We got the 4 in the middle, 1, 2, 3, 4, plus the 4 on the outside. We got the 9 in the middle, plus the 4 on the outside. We got the 16 in the middle, plus the 4 on the outside. Right? Okay, so I'm going to let you fill in the rest of it. Now, what I want you to notice is this is not a constant rate of change, because this would be plus 3, but then we got plus 5, but then we got plus 7. So we're not adding the same number. We're also not doubling, right? If you double 5, you don't get 8. If you double 8, you don't get 13. So it's not an add pattern, and it's not a multiply pattern. It's a different pattern. But it all has to do with the square, okay? So one of these questions, consider the inner square What is the relationship between the step number and the number of tiles in the inner square? Okay, well, the step number is 4. The number of tiles is 4 squared in the inside, plus these 4 on the outside, right? The number of tiles here is 9, plus the 4 on the outside. It's through the step number squared, okay? So the relationship between the inner square, this guy, number of tiles there, and the step number is the number of tiles in this guy is the step number squared. Okay, cool. Let's talk about the pattern here. Let's see if we can figure out how we got these numbers. Okay, right here. This is like a square, right? We have the inner square, and we know we multiply like the base times the height to get the area. So this one's not super interesting, but this is 1 times 1 plus 4. Or in other words, 1 squared plus 4. Okay, where does that come from? This is the 1 times 1, the 1 squared, it's the area of that box, plus the 4 on the outside. Okay, let's look at step 2. Here we got 2 squared, right? 2 times 2 is 4. So I got 2 times 2, or 2 squared, plus 4. Okay, this guy, 3 times 3, that's 9, right? Plus 4, we know that's 13. But 3 times 3 is 3 squared plus 4. Okay, and this one, 20, was 4 times 4 plus 4. That's 4 squared plus 4, right? 4 times 4 plus 4. So what's the same? The 4 is the same. 4, 4, 4, 4. That's the outside 4, right? What's changing is the step number, the figure number, 1, 2, 3, 4. But notice the figure number is right here. Figure number, figure number, figure number, figure number. So the figure number is the number, the length, I guess, of one of your sides of your square. And if you square it, you get the number on the inside, and then you add the 4 corners. Okay? So what equation? Well, it's going to be really similar to this. Okay? So how do you get step 4? You square it and add 4. How do you get step 5? You square it and add 4. Okay, well, how do you get step n? The number of tiles, t, at step n? Well, it's the number, the figure number, which is n. We square it, and then we add 4 to it. Okay, this is the hardest part to get, of course, so I wanted to kind of help you out with that. But you're going to fill in the rest of this. We talked a lot about it. I didn't write everything that you needed. You're going to have to write some of this stuff yourself. I did, help you with figure 4, but you can kind of see the pattern from there. So use this pattern, describe what's happening here, find number 10, fill in the rest of the table, right? Write it out. The more that you write it, the better you'll understand it. So use your words there. Okay. All right. Last page. Okay. Which of these had a constant rate of change? Well, constant rate of change is linear, right? There's only one. It's the first one. This guy adds 4 every time, right? That's a constant rate of change. Okay, this guy doesn't add the same amount. It adds 1, and then it adds 2, and then it adds 4, and then it adds 8. So the rate of change is changing. Now, we multiply by the same number, but rate of change means are you adding the same thing every time? Okay, this one, we add 3, then we add 5, then we add 7, then we're going to add 9, right? So we're not adding the same thing every single time in pattern 2 and pattern 3, only in pattern 1. Okay, which patterns grew the fastest? Okay, I'll let you kind of look at that and explain. All right, this is where the hard part comes in. I'm going to help you set this up. Okay, we want to graph the relationship between step number and number of tiles. Okay, so down here, we're going to have step number or figure number. Okay, over here, we're going to have number of tiles, almost kind of like the area, if you will. Okay, now we're going to graph all 3 patterns on the same axis. Okay, so number of tiles is dependent on step number. That's why step number is independent and tiles is dependent, right? Kind of like an X and a Y. But this is like an N and this is like a T. Okay. And we're only going through steps 1 through 5. Sorry, I got to jump back and forth. Steps 1 through 5. But we're going to do all 3. So the number of steps we need, we can have 0. Let's do a 0. Let's do a 1, a 2, a 3, a 4, and a 5. Now we have a lot of space here, so we can use, we can go 1, 2, 3, 4, but let's just space them out. So here's 0. Let's do 1, 2, 3, and then we'll put our 1, and then we'll go 1, 2, 3, and then we'll put our 2, and then we'll go 1, 2, 3, and we'll put our 3, 1, 2, 3, we'll put our 4, 1, 2, 3, we'll put our 5. I'm just spacing these out a little bit. You don't have to space in the same way. That's just going to make our graph look nicer. You could space them out 4 spaces away from each other, or 5 spaces away from each other, or whatever you want. You could also put them right next to each other, but again, that's going to look really crowded. Okay. Should our graph be discrete or continuous? Okay, well, let's take a look. Does it make sense to have a figure 1.5? Probably not. Does it make sense to have a figure 2.7? Probably not. So the in-betweens don't count here. Now, we did add a figure 0, okay, but maybe a negative figure might be kind of weird, right? So maybe probably not negative numbers. We basically only want whole numbers for our figures. Maybe 0, maybe 1, 2, 3, 4, right? We don't have any in-betweens, though. So our graph is not going to be connected. It's going to be disconnected. It's going to be discrete. We talked about independent and dependent variable. The only thing we have to figure out is if we have 3 different patterns in the same graph, they're going to overlap. They're going to look it's going to be kind of scrunched here. So what we're going to do is we need to pick a shape for each pattern. So let's do pattern 1, call it P1. We'll do dots for P1. Okay, for pattern 2, let's do diamonds. For pattern 3, let's do squares. Okay, that will kind of help us to distinguish between each pattern. So what we're going to do is we're going to go back to the tables that we made, and we're going to graph them. So we're going to take this table, and we're going to graph these as coordinates, right? This is kind of like an X and a Y. Really, it's an N and a T, but whatever. This is our independent. This is our dependent. So 1, 5 is a coordinate. 2, 9 is a coordinate. 3, 13 is a coordinate. So let's plot those. Now, pattern 1 we're going to use dots for. So here's pattern 1. Let's just go by ones up this way because we got to be able to fit a lot here. So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Okay, I'll let you finish that out, but that's kind of how it's going to go. So at step 0 for pattern 1, we had 1. We can include that. You don't have to include that one if you don't want to, but let's go ahead and put it on there. Okay, at step 1, figure 1, we had 5. Okay, so 1, 5 is our coordinate. 1, 5. Okay, and at step 2, we had 9. Okay, and at step 3, we had 13. All right, so you can see that we have a constant rate of change here, right? You can see that we could connect these with a line. Of course, we're not going to because, sorry, I made my point in the wrong spot. Dang it, shouldn't have spaced them out so much. We're not going to connect them with a line. We talked about this is not continuous, it's discrete. So this is our graph. We're going to keep extending this pattern until we have them all 5 of them, right? You got to plot 4 and 5. That's your job. But you can see that what's happening. Okay, now let's start pattern 2. Okay, you got to finish pattern 1. We haven't finished graphing it. You're going to finish that one on your own. Okay, pattern 2. All right, so we got 1, 2, and 2, 4, and 3, 8. We could also start with 0, 1. Okay, but we're going to graph this one differently. We're going to use diamonds for this one. Okay, so the first point was also 0, 1. Okay, so let's put a diamond around the dot to show that they're both there. Okay, next we had 1, 2. That was our next coordinate, 1, 2. So let's put a diamond there. Okay, and then we had 2, 4. Right, let's put a diamond there. And then we had 3, 8. So let's put a diamond there. Okay, now you can kind of see that this is actually curving. The dots, if you could connect them with a straight line, but the diamonds you can't. It's like a curving figure. Now we don't want to connect them because again this is discrete, but you should see the same pattern. So the next one, because this is a doubling pattern, is going to be up here actually. Okay, so finish it off because you got another step to do for pattern 2. Okay, and then you're also going to go back and do pattern 3 as well. Okay, so we want a graph. Pattern 3 is going to be squares, so it's going to be a different pattern. We wanted to be able to compare these patterns. So finish the dots for these guys, finish the diamonds for pattern 2, go back to pattern 3. Okay, there's your coordinates. 1, 5, that's a coordinate. Put a square, like a little, instead of a point, put like a little tiny square. So we use a different symbol. 2, 8, that's a coordinate. 3, 13, that's a coordinate. 4, 20, that's a coordinate. We're graphing this table, all 3 actually, on the same graph. So we can compare and see how these patterns change. One of them's linear, constant rate of change, other one's not so much. Okay? Kind of a long explanation, but we did this over basically, or we're going to do it over 2 different class periods. So we are going to turn this in. You will get points for it. So if you're at home, this is a little bit of what we did on Monday and Wednesday for A cohort. For B cohort, we started this Tuesday. We're going to finish it Thursday. And then we're also going to talk a little bit more about sequences in the next lesson. Okay, so thanks for watching. Finish this guy up. Hopefully that should help you get through it, but that's some hints for you.